Hi everyone, Tutor Fortune here. So in this video, I'm going to show you how you can come up with the resonance structures for a particular molecule or atom, and also how you calculate formal charges. Okay, so I'm going to use part A there to show how you can come up with the resonance structure and also calculate formal charges for of a particular molecule or atom. Okay, so we have our CO3, then there's a 2 minus there. Okay, so the first thing before you come up with the structure, the first thing you do is to uh, uh, calculate the total valence electron. Okay, so here what I'm going to do, I'm going to calculate the total valence electron for this ion. Okay, so I have my carbon there. What is the valence electron for carbon? It's 4. So I'll get my 4 plus, okay, I have 3 oxygens there. So I'll say 3 times uh, 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 the valence electron for oxygen is going to be 6. So times 6 there. Plus, so I'll consider this charge here. So this charge means that if 2 electrons were gained, okay, so I'll add those 2 electrons there, okay. So making my total valence electron to be equal to, so I'll summate this, I get a 4 plus, here is 18, okay, plus 2, which is 24. So that's my total valence electron here. So let me now come up with the structure, okay. So remember carbon, this is carbon. This carbon can form 4 bonds with other atoms, okay. So now we have 3 oxygens there, okay. So meaning this carbon is bonded to 2 oxygen with a single bond, okay. So it's bonded to 2 oxygen with a single bond and 1 oxygen with a double bond there, okay. So that's what you have in that there as a carbon, our central atom, okay. So now take note, we still have this total valence electron of 24. So now what was happening here for carbon to form this bond, okay? So this carbon was donating 1 electron to this, okay? Also oxygen was donating one electron to this, forming this one covalent bond there, okay? Same happened to this oxygen and same to the carbon as well. So this carbon donated 2 of its valence electrons there. So meaning it remained with 2. So those 2 remaining ones, it donated them here. So all the valence electron for a carbon have been donated. You can see there it donated 2, here it donated 1, and here 1. So meaning 4 of them have been donated. Okay. Then we have this oxygen donating 1 electron, and this one electron, and this oxygen also donating 2 electrons there. So now, you know the valence electron for oxygen is 6, okay? So when it donates 2, meaning it will remain with 4. Those 4 are the ones which are forming those 2 lone pairs here, okay? You have 2 lone pairs, okay? Now, these 2 oxygen, okay? So these 2 oxygen, each has donated 1 electron to this carbon to form this bond here, the covalent bond, okay? So meaning in a normal circumstance, when oxygen donates 1 electron, one of its valence electron, it's supposed to remain with 5 valence electron, okay? Now, you can see in our ion, this ion has gained 2 electrons, okay? So meaning where are we going to put those 2 electrons? So let's write the 5 one, the 5 remaining electrons there for this oxygen. So it has remained with 5. Also this one has also remained with the 5 electrons there, okay? So those 2 electrons are put now here where this oxygen is gaining is gaining 1 electron, okay? So to form another lone pair of electrons, so that we have 3 lone pairs there, okay? So even here, it will gain another one. The 2 have been used. The 2 which have been gained have been used to these 2 oxygens, okay? So meaning these oxygen attached to a single bond who have 3 lone pairs each, okay? So that's what you are having. So from here, we can calculate the number of electrons which have participated in forming this molecule. If they are summating to 24, okay? So let's count them. So here, I'll start from here. So I have 1, 2, 3, 4, 5, 6, 7, 8 there. Okay, 9, 10, 11, 12, 13, 14, 15, 16 there, 17, 18, 19, 20, 21, 22, 23, 24. I have 24 electrons. So meaning all the valence electrons have participated in forming this molecule. So immediately when you do this, and then you find out that you're getting the same valence electron, just know that you're doing the right thing. Okay. So from here we have this our molecule. Now let's come up with a resonance structures for this molecule. Okay. So we have this as one of the structures. Okay. So resonance structures are some of the other structures you're going to get from this molecule. Okay. So we have a 2 minus there. Okay. So when writing resonance structures, always indicate this arrow. Okay. To show that you're getting a resonance structure. Okay. So now we have this carbon. Okay. And this oxygen with a single bond. It's having these electrons there. Okay. So this oxygen can drop 2 of its lone pairs of electrons to there. Remember, 2 electrons, it can form a bond. Okay. So meaning you have a bond here. Okay. When this oxygen drops 2 electrons there, it will have a bond. Okay. Now, when it's having a bond here, meaning you have this carbon is now bonded to 5 of the 5 bonds, which is a bit unstable. So when this oxygen drop 2 of its electrons to form a bond there, this bond to the other oxygen will open like that. Okay. So you have a new structure being formed. So you have a carbon. Okay. Now this oxygen on top, remember this has opened. Okay. So meaning it will have a single bond. Okay. Then you have now 6 lone pairs on this oxygen. So those electrons now have gone here. Okay. So also have 3 lone pairs as well to this one. Okay. Then this one, since it has dropped electrons there, so meaning you are going to have, okay. So this is a lone pair. Okay. So meaning you are going to have a double bond here. Okay. So you have this oxygen. Now this oxygen will have 2 lone pairs. Remember, it has dropped 2 of its electrons. Okay. So this is another resonance structure you can get from this. Okay. You can still get another resonance structure from that. Okay. Let me just reduce that. So you can get another resonance structure there. So how? So remember this oxygen again, it's having these lone pairs and a single bond here. So it can also drop these electrons there. Okay. When it drops these electrons, this carbon will have 5 bonds, which is a bit unstable. Okay. So what will happen? This will open. Okay. And the electrons will drop there. So we have another structure now. Okay. So this carbon, this will be bonded to this oxygen, still having 3 lone pairs of electrons. Okay. Then this has dropped electrons. So the double bond is now there. We have 2 lone pairs of electrons there. Okay. Then this oxygen now will have a single bond. Okay. So you have a single bond like that. Okay. So meaning it will have 6 lone pairs of electrons. Okay. So these are the resonance structures for this ion. Okay. So now let's calculate the formal charges. Okay. Let's calculate the formal charges. So the formula for formal charge. So formal charge is given by, so you get your valence electrons, okay, minus. So you're going to get the non-bonding electrons, minus a plus, okay, so there's a plus there, plus the number of bonds. So you get the number of bonds. So this is going to give you the formal charge, okay? So let's start with the oxygen with single bond. So single bond, oxygen. So single bond, oxygen. So what are we going to have here? So single bond, oxygen. So what are we going to have? What is the valence electron for oxygen? So any oxygen will have a valence electron of 6, okay? Minus, okay? What are the how many non-bonding electrons are you having? So these lone pairs of electrons are the ones which are non-bonding electrons, okay? So you can see there, these oxygen with single bonds, they're having about 6 non-bonding electrons. So you get your 6 there. Plus, how many bonds are you having? Okay, so you can see you're having single bonds, so you're having one bond. Okay, so the formal charge for this oxygen with a single bond is going to be, so here you have 6 plus 1, which is 7, which is 6 minus 7. Okay, so this will be equal to -1. Okay, so meaning these oxygen with single bonds, they have a formal charge of -1. All of them, okay, as long as they're having a single bond, they have a formal charge of -1. All oxygen with a single bond, they will have a formal charge of -1. Okay. So let's go to the second one, which is the oxygen with a double bond. Okay. So double bond. Oxygen. Okay, so let's check what's the formal charge for this oxygen with a double bond. Okay, so you know the valence electron for oxygen is 6. Okay, minus the non-bonding electrons now they are 4. Okay, plus, so the non-bonding electrons are these bonds, they don't pair, they are now 4. Okay, so plus the number of bonds, you can see this oxygen with a double bond, they're having 2 bonds, okay? So plus 2, which is 6 inside there. 6 minus 6 is giving you 0. So meaning all these oxygen with a double bond, they're having a formal charge of 0, okay? You have a formal charge of 0 there, okay? So let's go to the central atom. So our central atom is carbon, okay? So let's also calculate uh, formal charge for our carbon. Okay, so here we have the valence electron for carbon, you know, it's 4. So for our carbon, so the formal charge for carbon here, so the valence electron is 4 minus the non-bonding electrons don't have any lone pairs there. All electrons are involved in bond. Okay, so you have 0 there. Okay, then plus the bonds. So you can see that each carbon here it's forming about 4 bonds. Okay, so that's 4. So meaning the central atom carbon will have a charge of 0. So this is having formal charge of 0. Same this one 0. Same to this one 0. Okay, so this is how you can come up with the resonance structure and how to calculate the formal charges of these molecules and ions. Okay, so now for these other questions, the remaining questions and other tutorial sheet solutions, the videos for these solutions have been uploaded on the website. So you can just simply subscribe with us. So let me show you how you can subscribe with us and how you can get access to those okay, so those solutions. Okay, so you simply open your browser. Okay, so I open my browser like that. Okay, then you type Discrete Learning Institute to come Discrete Learning Institute, then you open there. Okay, then when you open, you see something like this. Okay, so what you are going to do, you create an account. Okay, if you don't have an account, you create an account. Okay, after creating an account, you go to the course of your choice. Okay, so let's say if you want to subscribe for chemistry, you go and pay for chemistry. Okay, once you pay for chemistry, you should be able to open a folder like this. Okay, so when you open, you find these folders here. Okay, so there's one written general chemistry and the other one. So you go where it's the one written general chemistry. You go there. Okay, when you go there, there are these folders. So depending on what you want, so there are lessons and tutorials for the live classes, the recorded classes. You find them there in that folder. Handwritten solutions, you find them in that folder. Labo samples, laboratory samples, you find them there. Past paper, quiz test, exam papers, you find them there. Okay, now for tutorial sheets and assessment, you will find them here. So like the one we are solving is a tutorial sheet. So if you want video solutions or a written solution for the tutorial sheet or assessment, you go in that folder. So you open it like that, okay? When you open, you see these universities. So you choose your university. For example, I'll choose UNLAS there, my university, okay? Then I go in this folder. So there's first semester and second semester, okay? So you choose the semester you are in, okay? Then I open my folder there for the semester I'm in. Okay, let me just wait for it to open. Okay. Okay, so when it opens like this, you have these intakes, okay? There's January intake, 2025 July intake, okay? So you go 2025 July intake, depending on the intake you want, but definitely you go in 2024 July intake. So you find these tutorial sheets, okay? So you have your tutorial sheet on periodicity, your tutorial sheet on chemical bonding, units and measurements, gas laws, and also stereochemistry. Okay, so the tutorial sheet we are solving is on chemical bonding. Okay, so you enter in that folder written chemical bonding, then you find the video solution. And if you want for these other tutorial sheet solutions, you go in these folders respectively. Okay, so that's how you can subscribe with us and benefit with our classes. Okay, so we'll end here. Have a blessed day or evening.